Now let's look at our second example Scylla contract, which is the crowdfunding contract. The crowdfunding contract allows a person to raise funds through donations from the community, and in this example, the donations would be made in Zyl. This contract has three immutable variables: owner, max block, and goal. Owner represents the address of the person who is running the campaign, and max block represents the maximum block number to which the campaign would run to. And goal refers to the minimum amount of QA without which the project cannot be started. So we'll initialize these immutable variables. Also, the contract maintains two mutable fields, backers and funded. Backers is a field map and funded is a Boolean flag which represents whether the owner has already transferred the funds after the campaign has ended. Also, it has three transitions: donate, get funds, and claim back. Donate allows anyone to contribute to the crowdfunding campaign. Get funds allows only the owner to claim the donated amount and transfer it to the owner address. Claim back allows contributors to claim back their donations in case the campaign is not successful. So the campaign will not be successful when the goal is not reached and the max block has the blockchain has passed the max block limit that was mentioned in the contract. Max block acts as somewhat similar to time in this scenario. So max block signifies the block number to which the event would run to. Also, there's this concept of sanity check for contract parameters, and we have to ensure that the goal is a strictly positive amount, and we use a contract constraint for this. We look at this when we do the actual coding work. Okay, so now let's create the crowdfunding contract. So I've just named it crowdfunding.Scylla, and as usual, our first line of code is we mention the Scylla version. This case it's 0. And then we import any utils. So here we'll use Boolean utils, so bool utils. And then we mention the library part of the contract. So library crowdfunding. We'll come back to adding content to the library part of the contract in just a moment. Let's first define the skeleton of the contract. So after the library part of the contract, we have the contract definition itself. So that's done by using the keyword contract, then the contract name. And then we mention the immutable parameters. So first is the owner immutable parameter. Then we have the max block immutable parameter, which is of the type block number. And then we have the goal. It will be an unsigned integer. So after defining the immutable variables, we need to consider the contract constraint. Here the constraint is on the immutable variable goal, and we have a constraint that this should be positive. So contract constraint is a requirement on actually the contract's immutable parameters, and the syntax for defining a contract constraint is this. This is done using the with keyword after the immutable variables are declared, and the constraint must be an expression of type Boolean. And if no constraint is declared, then the constraint is assumed to be simply true. And if the constraint is checked when the contract is deployed, and if it evaluates to false, then the deployment fails. Otherwise, if it's true, then the deployment succeeds. So now let's add the contract constraint for the goal variable. So we use the keyword with, then let's define variable 0. Now we'll apply the condition to check whether our goal is less than 0. And we do that by using the built-in operator, built-in less than 0 goal. So here if goal is less than 0, then the contract deployment will fail, otherwise it will succeed. And let's finish this constraint by using this. So this is our constraint, and we can comment that this is the contract constraint. After defining the constraint and the mutable variables, we look at defining the mutable fields. So as we had mentioned before, we define mutable fields by using the keyword field, then the name, and then the data type. So here field is a map, and it's a map between the address, between a user's address and the amount that they have donated to this crowdfunding contract. And we initialize the map as an empty map using the emp keyword. Also, we need to have a mutable field for funded, as was mentioned in the contract specification, and this is of type boolean, and we initialize it as false. Okay, so now we have defined our mutable and immutable variables. So as was mentioned in our contract specification, we need to have 3 transitions. The first one is transition donate, and this doesn't take any arguments. Corresponding to this transition, we will have 2 procedures, and the first procedure is donation event, which takes in an argument failure of type bool and an error code, which we'll define later. This is an integer, and let's end this procedure and also end the donate transition. Also, we'll have one more procedure which is perform donate, and this also doesn't take any arguments. We'll define these procedures and transition in just a moment. Our second transition is get funds. So we have get funds, and the corresponding procedures, we have again 2 procedures that are corresponding to this transition. The first one is procedure get funds failure, and this takes one argument, which is error code, which is an integer type. And we have a second procedure, which is perform get funds. Okay, so now let's move on to our third and final transition, which is claim back. This also doesn't take any arguments, and it has 2 procedures associated with it. The first procedure is procedure claim back failure, which takes one argument, error code, and this is of type integer. And the second one is procedure perform claim back. And we end this procedure as well. So this is the structure of a contract. We have our utils, then we have our library, our contract definition, our contract constraint, mutable variables, and our 3 transitions and their corresponding procedures. Now let's also add some comments to this contract to make this look a bit clearer. So here we have our utils. This is our library part of the contract. Then we have the contract definition, contract constraint, and here we have our mutable variables.
Mutable fields.
Also, let's segregate our transitions. So here this is donate. Then this is get funds. And then we have claim back. Okay, so now let's check that have we made any syntax errors till now. So I'll use the Scylla checker, and we get one error. Okay, so here I forgot to have this as capital. Now let's check again. Now it says fine. So now let's actually start with our transition donate, which is the most important transition. Inside donate, we need to check that when the person calls donate, the block number of his transaction should be less than equal to the maximum block. So we'll write one library function that compares whether the block number is less than or equal to another block number. Coming back to our library part of the contract, let's define our function for comparing two block numbers. So let's call the function blk, which represents block, and less than equal to. And this function takes in two arguments. First is block number 1, which is blk1 and is of type bnum, which is block number. Second argument is blk2, which is again of type bnum. We need to have two checks that blk1 can be less than blk2 or blk1 can be equal to blk2, and if either of these two conditions come out to be true, this function blk underscore leq should return true. So for our first check, let's store the calculation of a check in a variable bc1, and we use built-in blt blk1 blk2. Now what this blt does is this checks if b1 is less than b2 and it returns a bool, and here b1 and b2 are block numbers. So here if blk1 is less than blk2, then bc1 will be true. Then for our second check, let's use the commonly used one, which is eq, which is the equality operator, and we use blk2. And then finally, we compute the logical OR of bc1 and bc2. If either of these is true, we want to return true. So logical OR is computed using ORB keyword, and we use bc1 and bc2. As you can see in the Scilla documentation, ORB computes the logical OR of two bool values. Now let's move back to our transition donate. We store the current block number by using this syntax and block number. So what this does is gets the current block number and stores it in this variable blk, and then what we do is we apply the check blk leq and we pass in blk and max block. So blk here is the block number when this transition was called, and max block is the max block immutable variable which is mentioned here, which is the maximum block until which this crowdfunding campaign should run. And let's store the result of this computation in another variable, which is in-time. Now we'll check whether in-time is true or false, and then we'll handle that accordingly. We'll do that by using the match operator. So match in-time with, and just so that I don't forget, I add the end here. And if it's true, then we are going to call the procedure perform donate. If it's false, then we are going to call the procedure donation event. And this donation event takes two arguments. One is failure, the second is error code. So we'll come to error code in just a moment, but for failure in this case, it should be true. So let's define another variable true so that we can pass it to this procedure. So T, and here our error code would be missed deadline code. Coming to this missed deadline code, this is similar to what we had in our Hello World contract. These codes are important because when we want to emit events through the contract, the developer would need to know of codes of what happened in the event. So we could have one code for when the donation was successful, one code for when someone tried to donate but he missed the deadline, then one code for if someone tries to claim the funds but that address is not the owner, and so on and so forth. So now let's actually define these codes in the library part of the contract. So we'll define this just below the functions. So the first code is the accepted code, which is when the transaction got accepted and the person was able to donate funds. And this is of type int32 and the value is 1. Then we have missed deadline code, which has the value 2. Then we have the already backed code, which is when someone has already backed this crowdfunding contract. Then we have not owner code, which is when someone tries to do something which only the owner of the contract should be able to do. Then we have the too early code, which is when the owner tries to retrieve the amount that is donated to the contract before the max block number is reached. Then we have let got funds code. We'll look at this in just a moment when we look at some of the other transitions. We have cannot get funds code. And then finally our last code is cannot reclaim code. So we'll look at these in just a moment, but let's just write these down for our future reference. Let's check whether we have made any syntax issues till now. Okay, so I forgot to put this equality operator. Now let's check again. Yeah, so our code till now is working fine. We have written this transition donate, and this transition calls two procedures, perform donate and donation event. So now let's write these two procedures. Looking at this procedure donation event, what it will do is it will emit an event and it will emit the respective code associated with that event. So what it will do is it will check if failure is true or false. So it will do match failure, and it will check if this is false, then it will emit an event which is donation success. And then it will say donor is the address of the sender. And remember, procedures also have access to this sender implicit variable, and it gets the value from the transition that is being called by the sender. And this transition, as you remember, this donation event procedure. And the amount is equal to the amount. And this is again an implicit variable. And the code here is the accepted code. So the accepted code, as you can see, is 1. So this 1 will be passed here. And we just add 1 semicolon. And then we emit this event. So this is the case for when failure was false. And then let's handle the case when failure is true, which is that the donation was a failure. So event name in this case would be donation failure. Donor is same as above, which is underscore sender. And we just specify the same values as was mentioned above. The difference is the code will be the error code, and the error code is passed as an argument. And in this case, when it was called through this transition donate, error code is missed deadline code. And we add the semicolon and then we emit this event. And now let's end this match statement as well. So this is our procedure which is written. Now let's come to this perform donate procedure, which gets called from here when the value is true. And let's look at perform donate. What this perform donate does is it checks whether the person who is calling donate, if he had already donated by looking at the backer's map, And if he had already donated, this perform donate calls donation event and passes the error code as accepted already backed code, which is mentioned here. Otherwise, it updates the value of the backer's map to reflect the address of the sender and the amount he has donated, and it calls donation event with accepted code. So now let's code this perform donate procedure. So to check for existence in a map, we use the exists keyword. So exists backers, and we pass in the sender address, and sender, this implicit variable, is also accessible to this procedure because it was called from this donate transition. And this will either return true or false, and we can use the match expression to check what to do when it's true and what to do when it's false. So if it's false, which means that this address doesn't exist in this backer's map, so the contract will accept that amount using the accept keyword, and we'll update the backer's map. So backers underscore sender, and we set the value as the amount that is passed. And we call donation event, and donation event is passed in C. So in this example, if it's false, so failure would be false, which means success would be true. So we have donation event C, and we pass in the code which is accepted code. Now let's look at the true condition. So we have true, and then what we do is we just simply pass donation event C, and the code is already backed code. Already backed code. And we just need to end this match and we're done. So our donate part of the contract is now done. Let's check if we have any errors. We don't have any errors till now. So in the next video, we'll look at the other two transitions, which is the get funds transition and the claim back transition and their corresponding procedures. So take care. See you soon.